Today we're going to talk about similar triangles and congruent triangles. So let's start with the similar triangles. So to work with similar triangles, we need to remember how to solve a proportion. So I'm going to go over how we solve a proportion first, just to remind you of that real quick. So solving a proportion, I'm going to cross multiply here. So I end up with 9 times 12 equals 16 times x. And then from the 9 times 12, we get 108. And then that equals 16x. Divide by 16. And x is 6.75. So solving proportions is useful because when you're working with similar triangles, obviously you know the sides are proportional. So you can just set up a proportion to find missing sides. Now this one has a little bit more algebra. So we're going to end up with 18 times 12. Doesn't matter which side or diagonal you start with. And then 9 times x minus 3. 18 times 12 is 216. We're going to distribute that 9 in and get 9x minus 27. Add 27 to both sides. And I get that 9x is 243. And then we just need to divide by 9. And we get that x is 27. All right, so let's look at different ways that we can prove triangles are similar. There are 3 ways we can prove triangles are similar. We have AA, which stands for angle-angle similarity, SSS, which is side-side-side similarity, and SAS, which is side-angle-side similarity. So for angle-angle, all that means is that 2 triangles have 2 angles that are congruent. If those 2 angles are congruent, then the third one has to be congruent because, they have to add up to 180. So that would make the triangles similar. Sometimes you'll see it referred to as AAA, but it doesn't really have to be AAA because as long as 2 of them are congruent, that third one has to be congruent. Then we have SSS, which the last 2, SSS and SAS, also play a part in congruent triangles. So it's important to differentiate between the 2. So for SSS similarity, this can prove that 2 triangles are similar if all corresponding sides are proportional. Then the triangles are similar. And then for side angle side, you have to have 2 proportional sides and an included angle that is congruent. And so we'll see examples of each one. On the triangle similarity one, this one right here, it says determine if the example below, if the examples are similar by angle-angle. If yes, write a similarity statement. So you can see that this angle is congruent to this angle is congruent to this angle. So that is AA. So the third angle will have to be congruent. So we can write a similarity statement. And the order of the letters matters. You want to make sure they match. So I could say triangle ABC is similar to triangle. So since A is congruent to D, I want to make sure that I put D first, and then E, and then F. So make sure you keep them in the correct order, or it's not a valid similarity statement. On the bottom one, you can see that we only have 1 congruent angle, which is not enough for angle A. For angle-angle. But we have these 2 angles right here that are vertical angles, and we can always assume that vertical angles are congruent. So if I mark those, now we have angle-angle here, and we can say the triangles are similar. So I could say triangle VXW is similar to triangle. V corresponds with Y. X corresponds with itself, and then Z. And so that would be another example of 2 triangles being similar by angle-angle. SSS, we just have to check that all the ratios are equal. So, for example, here on the first one, the 3 corresponds with the 6. So that'd be 3 over 6. The 5 corresponds with the 10. 5 over 10. And then the 4 corresponds with the 8. So if all these fractions are equal, then the triangles are similar by SSS. all of these will simplify to a half, so it's a little bit easier to tell. Yes, they are all proportional. So we can say that those triangles are similar by SSS. And we can write a similarity statement. Triangle QPR is similar to triangle TSU. All right, on the second one, we want to check them again. It doesn't matter which pair you start with. It doesn't matter if it's the big one on top, small one on top. So I can do, let's see, the 30 is going to correspond with the 24. 32 with the 25. And then 35 with the 38. Now this one's a little bit hard, 28, sorry. This one's a little bit harder to see because they don't all simplify the same fraction. So I would just divide them in your calculator. So if I do 30 divided by 24, I get 1.25. 32 divided by 25, I get 1.28. So already right there, I can see that it's not equal. I'll go ahead and divide the last one. 35 divided by 28, 1.25. So they're not all equal, so this one is not similar. The last one is SAS. So two congruent sides, or two proportional sides, not congruent. If I said congruent earlier, sorry, I'm getting mixed up with the congruent. I mean similar or proportional. Two proportional sides and an included angle that's congruent. Here's the included angle that's congruent. So now we just need to see if the sides are proportional. So we get 8 over 6 equals 20 over 15. You could also check this by like doing a little proportion to like see if they're equal. So you could do 8 times 15 equals 6 times 20 and see if that's equal. But I'm just going to divide them. When I do 8 divided by 6, I get 1.3 repeating. And then when I do 20 divided by 15, I also get 1.3 repeating. So these triangles do have two proportional sides and a congruent included angle. So they are similar by SAS. So I can say triangle JKL is similar to triangle MNP. Okay, now the bottom one, they're kind of like inside of one another. But we do have that congruent angle right here because they both share that point. They both share point A. So then I just have to check the proportions of the sides. So I'm going to do 25 over 15. And I'm going to see if it's equal to 21 over 12. So let's see. 25 divided by 15 is 1.6 repeating. And then 21 divided by 12 is 1.75. They are not equal, so these are not similar. And I think that's it for similar triangles. Yes, so we're going to move on to congruent triangles. Before we get into how to prove a triangle is congruent, let's talk about what a congruency statement is. This is a congruency statement. The order of the letters matters. As you can tell, A comes first, and A corresponds to D, which means that angle A is congruent to angle D. B is second, and E is second. So B and E correspond, and then C and F correspond. So use your similarity statement because sometimes your triangles won't be facing the same way. As you can tell on this one, it looks like this triangle is like flipped to like match this one. And so it says right here, a valid congruency statement must match all corresponding angles and sides. CPCTC, this stands for congruent parts of congruent triangles are congruent. That's a lot of congruence, but basically, if you prove two triangles are congruent, all of their corresponding parts are congruent also. So all their corresponding angles are congruent, and all their corresponding sides are congruent. So here it says list all the congruent angles and sides given the congruency statement. I'm just going to do one of them. But like, if I want to list all the corresponding angles on this, I would just match up the angles. Angle J is congruent to angle, whoops, I put triangle, the triangle symbol. Angle P. Angle K is congruent to angle Q. Angle L is congruent to angle R. Same thing with the sides. So I could say side JK. Notice how JK, those are the first two letters. So they're going to correspond to the first two letters on the other triangle. And then KL, so it's all about matching up the letters, is congruent to KR. And then JL is congruent to PR. And then we can write another valid congruency statement. So basically just change the order of the first one. So I'll do KLJ is congruent to, my congruent sign is awful. But you just want to make sure the letters match. So K goes with Q, so now I'll put Q first. L goes with R, and then P. And so that would be another valid congruency statement. And so on this one, they just want you to match up the parts. So KM, you can use the pictures. KM would go with CA. But you could also just look at the order of the letters. So CY would go with MP. So the letters are super important. Let's look at one that has numbers. So this one right here. So it says find each missing measure. So we know that the triangles are congruent because it's telling us that in the problem. So if they're congruent, we can assume that all of their corresponding parts are congruent. So BN, they want to know what BN measures. So if you look at our little table, our congruency statement, BN corresponds with SW. So since SW is 9, BN is also 9. TW corresponds with FN. So TW must be 14 because FN is 14. And then BF corresponds with ST, and that one is 17. Same thing with the angles. First one's angle W. Angle W corresponds with angle N. So angle N is 82, therefore angle W will also be 82. Angle B corresponds with angle S. Angle S is 67. So that one will also be 67. Let me label it 67 degrees and 82 degrees. And now they want me to find that third angle, angle F. F corresponds to T, but I don't have either one. So I can find it just by adding the other two angles, 67 plus 82, and then subtracting that from 180, and I get 31, which means that these other two angles are 31 degrees. Okay, there are 5 ways that we can prove triangles are congruent, as opposed to the 3 ways we can prove triangles are similar. Notice some of them are like the same as the similar ones, like this one and this one. Those are included in the similar one. So it's very important to differentiate between similarity and congruency statements because they're literally the same, but the definitions are different. So to prove 2 triangles are congruent, you can use side, 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 which means that all 3 corresponding sides would be equal. For side angle side, you have 2 sides and an included angle. The included angle means it has to be the angle between 2 sides. Like it has to be that angle. It can't be like this angle right here because that's not right between the 2 congruent sides. So make sure it's an included side. Angle side angle, kind of like the opposite. So you have 2 congruent angles and 1 included side. Angle side, you have 2 congruent angles. I'm going to use the same ones as I did on the other one. But this time, the side is not in between the 2 angles. So it could be this side or it could be this side, whichever one, as long as it's not between the 2 angles. And then HL, super important. HL is only for right triangles. So you can't use HL with any other type of triangle that is not a right triangle. And HL tells us that the hypotenuse is equal to the hypotenuse and one of the legs is equal to the other legs. So a right triangle can be proven congruent using any of these. So you're not just restricted to HL if you see a right triangle. You can use any of them. But HL can only be used on a right triangle. So when writing proofs, here's some of the reasons that you can use and some of the some of the reasons you can use when writing a proof, which we'll get to towards the end. But some reasons that sides are congruent. It's given, the definition of a midpoint, the reflexive property. What else? A bisector. Sometimes you'll see the word bisector. Let me write that in. And then reasons angles are congruent. You have it's given, they're vertical angles. Remember, vertical angles are always congruent. Alternate interior, alternate exterior, and corresponding angles are congruent, but super important. You have to have parallel lines for those to be true. And the definition of an angle bisector, which means it cuts an angle in half. All right, let's see if we can prove some triangles are congruent. So here we are. It says, compare the triangles and determine whether they can be proven congruent, if possible, by one of these, and write your answer in the box. So if you look at this triangle, we have one congruent angle here and we have one congruent angle here. Sometimes you can mark things congruent, but like you have to have a reason to mark things congruent. You can't just be like, oh, I'm gonna mark this. Like I can't just be like, oh, I'm gonna mark this side congruent to this side. So now it's angle side. So we want to make sure we have a math reason, and in this case, we would be able to mark this side congruent. Anytime the two triangles share a side, we can mark it congruent because if they share it, obviously it's like it's the same size, and so that's called the reflexive property. Whenever they like share a side, that'll make more sense once we start writing proofs. So this one is congruent by angle, side, angle. Number 2, we can mark this side congruent because they share it. So that one is side. This next one, let's see, we have an angle, we have a side. Sometimes I'll tell the kids to like label them because it'll help. And so, sorry, I almost canceled it. And we can see that it's angle, side. But it could also be ASA, so like they need to be sure that they realize that the side's not between the angles. This is a right triangle, so you can assume that it's HL, but, I mean, you can like start there, and then if it's not HL, you can check the other ones. We do have a leg congruent, and then here's the hypotenuse congruent, so it is HL. This next one, I can mark these angles congruent because they're vertical angles, but that still doesn't give me a valid congruency statement. I have two sides and an A, and it's not SAS because the angle is not between the sides. Sometimes some of the kids try to use this one. They don't do it on purpose, but they don't like realize, and then I end up with all these like bad words on my paper. So ASS is not a congruency statement, or sometimes they'll write it backwards. They just forget and they get confused with all the letters. But this one will be none. Okay. Next, see those black arrows? That's where the parallel lines come in. When we have parallel lines, we can mark corresponding angles congruent, alternate interior, alternate exterior. Like this could be our transversal, and I could mark this angle congruent to this angle because they are corresponding angles. Which I think your lesson last week was over corresponding angles, alternate interior, alternate exterior. So now you can see that this one is angle, side, angle. And I'm going to skip the rest of those. Let's get into some proofs. I think there's like one proof question on your homework, but they're not too bad. When you're writing a proof, you want to start with your givens. Anything that they tell you is given, you can write in like the first lines. And like whatever you're trying to prove, you want to write that in the last line. So I'm given one statement on this one, so that goes in the first line. So it says L is the midpoint. I'm going to abbreviate midpoint of KN and MP. So I was given that information. So the reason that it's true is because it's given. Now, whatever you're trying to prove goes in the last box. Sorry, my phone's ringing. And then the prove, again, prove goes in the last box. Okay. So from there, we can start like looking at what else could be congruent. So if you look at the triangles, nothing's marked. But we can mark these angles because they're vertical angles. So on number 2, if you mark something congruent, you need to write it down. MLK is congruent to angle NLP. And the reason those are congruent is because they are vertical angles. Now, that's all I can mark. They don't share a side or anything, but I can come up with more congruencies for my statement. It says L is the midpoint of KN. L is a midpoint. That means that this side is equal to this side. So if I marked it, I need to write it. KL is congruent to LN. Why? Midpoint. Definition of a midpoint. I should have wrote definition of a midpoint. It gets so long, like writing it over and over, so I always tell the kids, just write midpoint. But it is because of the definition of what a midpoint is. Now it says L is also the midpoint of MP. So it's also the midpoint of this line. So I can write NL is congruent to LP, also because of the definition of the midpoint. Now sometimes like the problem won't tell you that it's the midpoint of both like lines. Like if this would have just said L is the midpoint of KN, I would not have been able to assume this second one. It has to tell me that it's the midpoint of both so that I can like assume that they're both like being bisected or whatever. And so now look at my triangle and I can clearly see that the triangles are congruent by SAS. You have a side, you have an angle, you have a side. Let's do another one. Now this one has two given statements. See the commas separate them. Here's one, here's two. So I'm going to start by writing those in the statement boxes. And I'm going to write the prove in the last box. So if you just write the given statements and you write the statement in the last box and you write the given for the first two reasons, that fills up a lot of your boxes. I already filled in 1, 2, 3, 4, 5. 5 out of 10 boxes. That's already half. All right, let's go through this. So it says BD bisects angle ABC. So here's line BD. I'm going to extend it. It bisects angle ABD. If a line bisects an angle, they're going to want you to mark, they're telling you because they want you to mark two angles congruent. I can mark those two because it says it's the bisector of that angle. I cannot mark these two congruent because it does not say that it's also a bisector of angle ABC. So we can't assume that, but we can mark those. So ABD is congruent to angle CBD. And then the reason would be the bisector, definition of a bisector. Okay. Now, it also tells me angle BAD. BAD, so I'm going to mark it, is congruent to angle BCD. That's given, so I can mark it. It's given right here in that second one. Now, is there anything else I can mark? They do share side BD, so I can mark BD congruent. And so the way we would write that is we would just say BD is congruent to BD. BD is congruent to itself. And that is the reflexive property that I was talking about earlier. Now we can see that the triangles are congruent by angle, angle, side. Okay, I think this is the last example. So it says I have 1, 2, 3 givens. So it says S is the midpoint of QU. QR is congruent to ST. And RS is congruent to TU. And then my given goes in, whatever I'm trying to prove goes in the last blank. The first three are given. And let me mark them. I'll come back to the midpoint one. QR is congruent to ST. RS is congruent to TU. So that was given. Then it says S is the midpoint of QU. If S is the midpoint of QU, that means that this side is congruent to this side. So I need to write that down. QS is congruent to SU because of the midpoint. So definition of a midpoint. So the triangles are congruent by SSS. Thought I had an example with parallel lines, but I guess I don't. Let me see if I can find one real quick, because I think there's one on your homework that is parallel lines. Maybe this one? Nope, that one's not one either. Let's just use the picture from number 3, and I'll change like the given info, and we'll do another one. So I'm gonna draw this picture over here. I'm gonna try. Okay, well, close enough. So let's see. Q, R, S, Q, Q. So let's see. I'm going to say given QR is parallel to ST always say. S is the midpoint of QU, and let's also say that QR is congruent to ST. And so let's write a proof. So I'm just going to do a teaching statements over here. Reasons over here. Let me change my color since I wrote the problem in that. So we have 3 givens. 1, 2, 3. QR is parallel to ST. S is the midpoint of QU, and QR is congruent to ST. I think I'm going to need one more step, and then my proof can go on the last one, which I didn't even write the proof. I want to prove triangle QRS is congruent to triangle STU. So that would go in my last box. Triangle QRS is congruent to triangle STU. All right. So 1, 2, 3, 4, 5. First three are given. And let's mark them. QR is parallel to ST. We'll come back to that. S is the midpoint of QU, which means this side is equal to this side. So that's what's going to go on my last blank. You know what? I am missing a blank. I'm going to need number 6. So I need to erase that. So QS is congruent to SU, definition of midpoint. Okay, now number 3 says QR is congruent to ST, so I'm going to mark this congruent, and that's all it gives us. So then we're going to come in here and use the fact that we have parallel lines. If we have parallel lines, that's a hint that we need to look for alternate interior angles, corresponding angles, alternate exterior, all that kind of thing. Well, if these are my parallel lines, I can say that this angle is equal to this angle because they are corresponding angles. So let's write that down. Angle RQS is congruent to angle TSU because they are corresponding angles. And I can only say that because in the problem it told me that I have parallel lines. If it doesn't tell you have parallel lines, then you can't assume that you have any of those angle pair relationships. So now look at it. I have side, angle, side. So I can say the 2 triangles are congruent. Triangle QRS is congruent to triangle STU by side, angle, side. And there you go. I believe that brings us to the end. Yes, it does. Thank you.